Hi, welcome to this video on area of geometrical shapes. Some educational aids that you need: a geoboard and some rubber bands, or you can also use a dotted paper, pencil and ruler. For this video we are going to use a dotted paper. So in this dotted paper, the distance between two consecutive horizontal points would be 1 unit, and the distance between two consecutive vertical points would be 1 unit. So what do you think is the area of this square? So the horizontal distance is 1 unit, vertical distance is 1 unit, so the area would be 1 square unit. So you will be using this to find the areas of geometrical shapes. So here I have drawn a random geometrical shape, and then on the top left corner is our square for which we know the area. So the area of the square we already know is 1 square unit. So using this, can we find out the area enclosed in this shape? So the colored region is the area which we need to find out. So can you give it a try? It might appear a bit intimidating at first sight, but if you were to learn some basics about area, then it would be very easy. Let us see how. So we have defined a standard unit for finding the area. So instead of 1 unit by 1 unit, if our measurement is in terms of centimeters, so if it becomes 1 centimeter by 1 centimeter, then the area would be 1 square centimeter. So if we have this as the standard unit to find the area, what do you think are the areas of these shapes? So what we need to do to find the area, these areas, is just find out how many pieces of the 1 square unit area fit in these. So in the first figure we see that 2 squares fit, so it is 2 square units. In the second, 4 square units. The third, 6 square units, and in the fourth it is 20 square units, because 20 squares of 1 square unit fit in this shape. But what about these? Do we know how to find the area of these shapes? These are right angle triangles, acute angle triangle and obtuse angle triangle. So we'll find that out. So this is a rectangular shape for which we know how to find out the area. So what happens if I draw a diagonal in this rectangular shape? The diagonal divides the rectangle into two triangles, and these are right angle triangles. But what is the relationship between these triangles? We'll find out. We have this one triangle, second triangle. So do you think there is any relationship? So if I turn it over and move it, it will fit exactly on the first triangle. So these two triangles are of equal area. So what do you think is the area of the triangle, right angle triangle? It is half of the area of the rectangle, right? So can we find the area of the right angle triangles shown? What we need to do is we just need to fit a rectangle or a square around the right angle triangle in such a way that the hypotenuse becomes the diagonal of the rectangle or the square. So in the first case, the area of the right angle triangle becomes 0.5 because it is half of 1. In the second, it is 1.5, and in the third, it is 7.5 square units. But what about the acute angle triangle shown here? Do we know how to find out the area of this? Let us find out. So I have an acute angle triangle here, and as a first step I draw a rectangle around it. So do we see any right angle triangles here? We don't, right? So what we will do is we'll try to create some right angle triangles. So I draw a perpendicular line to the base DC of the triangle. So now I see two right angle triangles, And as a result of drawing the perpendicular, I also see that the rectangle has been divided into two smaller rectangles. So now can we find out the area of the right angle triangles? Of course we can, right? From the knowledge we have. So area of right angle triangle LMD is half of area of rectangle LMDA, and area of right angle triangle LMC is half of area of rectangle LMCB. So if I add up those, I get the area of the acute angle triangle LDC with which we started. So that is half of the area of the whole rectangle ABCD. Here it should be noted that the base of the rectangle of the triangle is the same as one of the sides of the rectangle, and the vertex opposite the base is on the opposite side of the rectangle. Only if this is the case, then the area of the triangle would be half of the area of the rectangle. So in this case, in the triangle PTSR, it won't be because T doesn't lie on PQ. And in the case of triangle XYZ, again it won't be half of rectangle UVWX because the base XZ doesn't coincide with the side XW of the rectangle. So what do you think is the area of this acute angle triangle? We just need to draw a rectangle around it. So that's the rectangle, and then we need to measure the number of 1 square unit squares in that. So how many are there? There are 20 such squares. So the area of the rectangle would be 20 square units. So the area of the triangle would be 10 square units. Now what about this? This is an obtuse angle triangle. How do we find the area of this? Let us find out. So ABC is an obtuse angle triangle, and we need to find the area of this. So what we can do is we can draw a rectangle around that, but then we see that base BC doesn't coincide with side NC of the rectangle. So we cannot say that the area of ABC is half of the rectangle. So we already know how to find the area of right angle triangle and acute angle triangle. Can we use the knowledge here? What we'll do is we'll draw a right angle triangle ANC, which is bigger than the triangle ABC. And what is the area of this? It is half of the area of rectangle ANCL. And then we need to remove the extra part, that is ANB. So if I draw a line MB, then area of triangle ANB becomes half of area of rectangle ANBM, and this needs to be subtracted. So once we do that, we get the area of our triangle ABC, which is half of the area of rectangle MBCL. So here if you see, the base BC of the triangle coincides with the side BC of the rectangle MBCL. The only difference is that the vertex A doesn't lie on the segment ML, but it lies on ML extended. So in this case, what do you say? What can you say about the area of TSR? It is not half of PQRS, right? Because T doesn't lie on PQ extended, and here also Y doesn't lie on UV extended. Now what do you think is the area of this obtuse angle triangle? So I draw a rectangle where the base of the triangle is the same as one of the sides of the rectangle, and then I find out how many squares are there. There are 10 squares, and also if you see, the vertex of the triangle, which is opposite to the base, is on the same line as the opposite side of the rectangle. So the area of this triangle is indeed half of the area of this rectangle. So how much is it? It is 5 square units. So if you know these fundamentals, then you should be able to find out the area of any geometrical shape having line segments. So now, do you feel that you would be able to find out the area of this enclosed geometrical shape with whatever you have learned, you can give it a try. So can you see some rectangular shapes, some triangular shapes, right angle triangles, acute angle triangles, obtuse angle triangles in this? And then if you were to divide this shape into triangular and rectangular shapes and then add them up, you should be able to get the area. So go ahead and give it a try. So let's do it together now. So if the area of this square is 1 square unit, then we need to find out the area of this closed shape. The secret to find out the area of this complex figure is in breaking a big problem into smaller problems for which we already know the solution. So can you find some triangles and rectangles in this big figure? So in the small part, I find 2 right angle triangles and 1 rectangle. So in this way, if I am able to find out all such triangles and rectangles in this figure, I should be able to find out the area of this. So let us start. So the area of this triangle is 1.5 because it's half of 3. Area of this rectangle is 12. Area of this triangle is 2.5. Area of this triangle is 7.5. This is 3, and then here is an obtuse angle triangle. So the area of that is 3. Area of this triangle is 12.5. Another obtuse angle triangle. Area is 5. This rectangle area is 18. 3, 7, 2, and then 3 smaller triangles of half square units. So we have broken up the big shape into smaller shapes for which we already know how to find the area. So in order to find the area of the shape, we just have to add these areas to get the area of this shape. So is this the only method to solve it, or do you think there are other ways of finding the area? Let us see. So another method which we will try, what I've done here is, instead of taking smaller units, I have taken a big rectangle, and then what I have to do is remove the parts that I don't want. So what is the area of this rectangle? It is 60. I don't want this part. This is a right angle triangle, so I know how to find the area of that, which is 1.5. so that I need to subtract. I need to remove this part. I know how to find the area. It is minus 10, and then this part should be removed, so minus 3. So the area of this shape would be 45.5. Now there is this obtuse angle triangle. I use the direct method. So I find the area, which is 3, and then for this shape again I use a bigger rectangle. The area of that is 40. I remove the part which I don't want. So this is minus 20, and this is minus 2.5. So the area of this shape is 17.5. Again I use a bigger rectangle, which is 12 minus 3, which is 9. And then here again a bigger rectangle. So the area of the triangle is 4.5, and I don't need this part. So the area of that is minus 1. So it is 3.5. So all I need to do now is add up these different values to get the final area. If you add them up, you still get 78.5. So this way you can try various ways of finding the area and see that every time you get the same area. So here are a few more geometrical shapes. You know the area of this small square unit, this 1 square unit. Using this, you need to find out what is the area enclosed in this shape, and this shape. So go ahead and give it a try. So you just need to divide these into smaller triangles and rectangles. So hope you had fun learning how to find the area. See you again in another video.